Hello and welcome back to Mini Rust in Rust. This is video 32. We are deep in some type checking. So what we're doing is we're writing a programming language which looks a bit like Rust but is interpreted. It's going to be like a convenient little scripting language you can use inside your Rust program. Or, I don't know, like my fantasy is that I would be able to, instead of writing bash scripts or Python scripts, I could write scripts just in a syntax that I love, which is the Rust syntax, but they work a bit like Python, I guess, is what I'd like. But this is never going to be anything useful, right? This is for, let's not pretend I'm going to get far enough through this project that it becomes a useful thing. But anyway, so we have an example here that we're using to push our way through the problems involved in writing a non-trivial program. So this is a non-trivial program that calculates factorial. And we've been looking at this while loop and making that work. And last time we got to the point where, like, the structure of a while loop not only lexes and parses, but also type checks. Now, we had a couple of to-dos in there to actually check the types of some things. Like, we need to check that this part, for example, is Boolean. And we're skipping over that for now. We also need to check that the body of this thing has a unit type, as in no type. But where we got to was the general structure of this works, but then the other thing that happens inside this while loop is some what I'm calling mutations, right? So basically some variables, some mutable variables, which is what these are, get changed. Their value gets changed by multiplying by something or by adding something. And there's no type checking code for that yet. It just crashes out when we get to that. So where it goes wrong is here. When we ran our tests, we got a problem on line 180, which is here, because of this big to-do thing here that says we should do something. And what we should do is follow the pattern of the rest of this code. We should call a function called type check mutation. And it's going to pass in, just like everything else, it's going to pass in the file contents, which is basically the source code that we're currently parsing, and then just the other information about this thing that we're currently type checking. So we're going to pass in symbol, the mutation token, and the expression. So just to talk a little bit more about this, a mutation is basically a left-hand side and then like a plus equals or something like that, and then a right-hand side. So left-hand side is just going to be a symbol. You can't have anything other than a symbol on the left-hand side of something like that. Mutation token is going to be a mutation token, like it's just specifically a really specific thing. And then the expression could be just any type of syntax tree. And our job when we're doing type checking is firstly to check the types, and secondly, to transform this syntax tree or box of syntax tree into a typed syntax tree, which is basically the syntax tree where all the things, we know the types or the type constraints on all the things in that tree. And we haven't fully developed these ideas, and I may have done it completely wrong or may not make sense, but this is the plan we're working to at the moment. So let's have a look at this function which we've just asked ourselves to make, which is called type check mutation. Where are we going to put it? Let's put it near type check assignment, because I feel like it's really similar to type check assignment. Could be wrong though. All right, so type check assignment type checks the right hand side first. So let's do the same thing. So yep, there's a thing called expression, which is fine. Now there is actually something we need to check here, which is that the expression has the same type as whatever the symbol points at. Now, at the moment, I happen to know that we're not really checking the types of symbols because we're not looking them up yet. But yeah, there should be some kind of error like this that comes out when you've done the wrong thing. You've tried to mutate the left-hand side with something that is not allowed on the right-hand side. But, it's not actually just always going to be the same type. Like, you can do like a times equal on something and pass in some different number type. And in some cases that will work, especially if they've implemented the trait called like, mul assign or whatever it's called. All right, so again, it's too difficult. We're not going to do it yet. We're gonna add a to do for checking that it's okay, and that will mean looking up that symbol token in our environment, which is all very interesting. We don't have an environment here. There's definitely more thinking and work to be done here, but we're not going to do it. So where are we going to put the to do? Somewhere we're going to say check that that expression has a suitable type to be on the right hand side of, let's write it out, on the right hand side of a mutation of this type of a value referred to by symbol, right? Something like that. So that's all to do, but I think what we're going to actually do here is going to be quite straightforward. We're just going to return a type syntax tree of type mutation, and we're just going to pass in the same stuff. So symbol, mutation token, and a boxed expression. Yeah, so we've got a new version of expression by type checking it already, and we just need to box up that to return it. And now what we need this function which just creates as a type syntax tree of that type, which should be similar to the others. These are just like kind of convenience functions. They don't do anything particularly clever, although we are starting to do some clever stuff, like an assignment always has unit type. I'm guessing a mutation also always has unit types, and let's copy that and see where it gets us. So we're going to return a type syntax tree. So we should have a self here and here. And I guess mutation token is okay to just move through like that. We'll see what the thing is. But the type of the syntax node here is going to be mutation, which already exists. So I've gone through and created these syntax nodes because they were used for non-type syntax trees, and now I'm using them for syntax trees. That looks wrong. There we go. And symbol is going to be symbol. And mutation token is going to be mutation token, and expression is going to be expression. Yeah, so these are really dumb things. Pretty sure a mutation has unit type, but let's double check that. Why don't we double check it? So what if we said there's too much code here. So a mutation is something like a times equals 2, right? Let's just print out a at the end. So what if we said let x equal a times equals 2? Maybe we'll put it in brackets just to make it make life easier. What's the type of x? And what is it moaning about? It doesn't like the fact that there are parentheses here, it doesn't need them. What if we print out a? It's okay with that. It doesn't mind me writing that as an expression. But the type of x is the unit type. So I'm pretty sure that's not the case. If I said let b equal 2, for example. So you can't, a let is not an expression in this sense. You can't let x be the result of letting b be 2. But it does look like you can let x be the result of multiplying a by 2. It's just that the type of that result is unit. So x doesn't actually there's no use to this. But it is an expression. which is interesting because it has side effects. So you could use it somewhere. Yeah, and it would be like if we did let x be true and, or like, I don't know, a is less than 20 and a times equals 2. And then like if we did some clever stuff so that it became Boolean as well. Which maybe we can't, so maybe this is fine. Anyway, you could imagine this side effect only happening if a was less than 20 or if a was greater than 20 or something like that. So that's really a deviation. Point is, the type of a modification, or at least a multiplication, in this case, is units. And again, yeah, if we add 2, the result of doing that is like it modifies a, but the answer you get back from that expression is of unit type. So no use really to write it like that. So that means that this piece of code here is correct. When you try and mutate, you end up with an expression of type unit, like so. All right. So what happens when we compile our code? We get another panic in our type checker. This time on line 155, which I'm guessing is some other thing that we haven't dealt with yet. Okay, yeah, so when we try and type check something of unit type, we get back, I mean, it's really easy, right? We're going to I think we can do it inline here. We can just say something of unit type. We do have to call a function. I think we do because, yeah, like there's actually a type syntax tree. There's more to making a type syntax tree than just, like, well, is there? Or maybe we could just say this. We'll find out. Oh, it needs to be wrapped in okay. There's a whole load of stuff. All right, so that's why we do these as functions. So let's make a function called unit. And let us put that first, I guess, because it's really simple, even simpler than leaf. And all these little helper functions, all they do is make a self. So I guess we should say self here, right? Oh, hang on. It's a result of self. So hang on, leaf doesn't return a result. None of these return results. Why do I need to return a result in this case? Because these are all called type check something. Oh, so I'm talking about that. Okay, so I guess we want to return an okay. I could write type check unit for uniformity here. Now this one doesn't need to return a result. Which means I don't need any of that. So I could return type check unit and write a little function called type check unit. But that seems like overkill maybe. So let's just see. So when we're creating a type syntax tree, it's going to have type of unit and is there a node at all? I think there probably is. Yeah, there's a node of type unit. So this will be something like this. No, it's going to be a syntax. Sorry, it's going to be a syntax node of type unit. Yeah, that's it. So unit type is like void in other languages, and it's confusing because there's a unit value. So if you write brackets in your Rust code, like say here, that's a unit value. Oh no, that looks like a function call, so that's really confusing. If you made a new function, and it maybe returned unit, if you say bracket bracket like this, or you say let x equal that, whatever, the type of x is unit, which is bracket bracket. This is a unit value, which has a type of unit. So those are both the same thing, which is why it's really confusing. Or rather, they both look the same thing. They're both written bracket bracket, but they have different meanings. So in this situation, we're parsing a value of type, a unit value, and type checking it and saying the type of a unit value is the unit type, but the value of the unit value is the unit value. So this syntax node : unit, that's a unit value. This type constraint : unit, that is a unit type. If that doesn't mean anything, then I guess you can probably ignore it. So the question is, are we okay with just saying OK type syntax tree unit here? Or do we feel that we should have a type check unit function? I think we're probably okay. All right. What happens when we run that? Oh, look, excitement. We have an error in our evaluator. So this code, this example code, has now been type checked successfully. All of this code type checks successfully. So we can go back to ignoring it, check our tests pass, and I'll see you next time. And I promise I'll do a commit between now and then. See you then.